Okay, this is the M1 paper from January 2024. This is question number 1, first question on the paper. And this is a statics question. It tells me that this situation is resting in equilibrium. Let's read through it and see what we've got. It says the figure shows a smooth ring threaded onto a light inextensible string. So straight away that's important. If it's a ring being threaded on, then later on when I'm going to do my work, this is the same string, so the tension will be the same throughout both of those parts of the diagram. One end of the string is attached to A, the other one's attached to B, as we can see in the diagram. There's a force of 2 newtons, which I can see acting horizontally, and it says the ring rests in equilibrium. Then all the stuff about line of action of horizontal force. It doesn't tell me theta. It tells me that tan theta is equal to 3/4. That's a standard thing. I'm actually going to attack that first when I'm doing it. Once I have done it, then they want me to find value of t and value of m. Okay, let's jump straight in and get started. So the one thing I have done is to just copy the diagram out under there, which I'll look at in a second. But I said, no, the first thing I'm going to do is if tan theta is equal to 3/4, you'll have seen this in a lot of my videos already. If tan theta is equal to 3/4, then that means that opposite over adjacent is equal to 3/4. Using Pythagoras, or actually you should know that there's a 3, 4, 5 triangle, we can work out the hypotenuse is equal to 5. So sine theta and cos theta we've now got. Sine theta is opposite over hypotenuse, which is 3 out of 5, and cos theta is adjacent over hypotenuse, which is 4 out of 5. Right, now I've done that, I can actually look at this diagram and say, what have we got going on? Well, as I said just a minute ago, the tension in the string then, it's the same string for both those parts there, so we've got a tension and a tension. What other forces have we got? I put the 2 newtons on because they gave me that in the diagram. So the only other force that we haven't mentioned is the fact that this ring has a mass of m, so we've got mg acting vertically downwards there. What am I going to do? Before I can start resolving horizontally and vertically, I just need to take this tension here and I need to just resolve it into horizontal and vertical components. So if that angle is theta there, then using my z angle, my alternate angles, I can see that that's going to be theta there as well, which means this part is going to be t sine theta, and this part is going to be t cos theta. So once I've got that, this is a pretty classic question now, I'm going to resolve horizontally, and I'm going to get that force there, the 2 and the t cos theta, they're going to be equal to each other. And then after that, I'm going to resolve vertically, and I'll get that those 3 forces all equate to equal to 0 as well. Let's do that properly though, formally. So explain to the examiner what I'm doing. A, resolve horizontally. I always say F equals ma, but we know that the forces are in equilibrium, so they're going to balance out. I'm just going to get that t cos theta equals 2, and remember we know what we know what cos theta is. So 4/5 t is equal to 2. So that means I can work out t straight away. Okay, so t works out to be 10 over 4. T is 2.5 newtons, and that was actually what I needed for that first part, so that's great. And then for part B, I'm going to resolve vertically now. When I resolve vertically, again, I say F equals ma, but what I'm looking at is what I've got. That one and that one counteract with the mg. So t plus t sine theta is going to equal to mg. T plus t sine theta works out to be equal to mg. And remember, we know what t is now. So 2.5 plus 2.5, what was sine theta? That was 3/5, is equal to mg. And then tidying all that up, I'll let you do that yourself. Multiply that all out, divide by g, obviously. M works out to be equal to 0.41 kilograms. And I'm going to do it to 2 significant figures because we've taken g as being 9.8. Okay, relatively straightforward first question. Hopefully that all makes sense to you.